Knowledge seekers. In this video, we will solve this interesting exponent problem from the Oxford entrance exam. We have to find all the roots of the equation, which means all the values of x, real and imaginary. The equation is a to the power of x plus 4 is equal to 4 to the power of x plus 2 to the power of x plus 2. So let us begin and write the equation. We have 8 power x plus 4 is equal to 4 power x plus 2 power x plus 2. Let's bring all the terms to the left hand side. So on the left hand side we already have two terms, 8 power x plus 4. Now 4 comes to the left hand side, becomes negative 4 power x. Similarly negative 2 power x plus 2. And this is now equal to 0. Now we can write 8 as 2 raised to the power 3 and 4 as 2 raised to the power 2. So this 8 becomes 2 raised to the power 3 to the power x. We will leave this 4 as it is, and this 4 becomes 2 raised to the power 2 raised to the power x. Now the last term is of the form a power m plus n, which is the same thing as a power m into a power n. So this can be written as 2 raised to the power 2 into 2 raised to the power x, and this entire thing is equal to 0. Now we know that if we have a power m power n, this can be written as a power m into n. So 2 raised to the power 3 to the power x becomes 2 raised to the power 3x plus we have 4 minus 2 raised to the power 2x minus 2 raised to power 2 becomes 4 into 2 raised to the power x is equal to 0. So let's rearrange the terms. We get 2 raised to the power 3x minus 2 raised to the power 2x minus 4 into 2 raised to the power x plus 4 is equal to 0. Now let 2 raised to the power x be equal to y, which means 2 raised to the power 3x is y cube. So I can substitute 2 to the power 3x with y cube minus y squared minus 4y plus 4 is equal to 0. Now let's try to find the first root by trial and error. If we substitute y is equal to 1, we get 1 minus 1 plus 4 minus 4, which is equal to 0, which means y is equal to 1 is one of the roots of this equation. Now we can factorize the left hand side by using synthetic division. So we have, let's write down the coefficients. We have 1 minus 1 minus 4 plus 4, and y is equal to 1 is one of the roots. So we bring this one down, which is the coefficient of y cube, and then we do the multiplication. So here we get 1 minus 1 plus 1 is 0. 0 into 1 is 0. So we get minus 4 here. Minus 4 into 1 is minus 4, and we get 0. So we get not x but y. We get y square plus 0y minus 4 as the second factor, which is the same thing as y squared minus 4, which means y minus 1 into y minus 4 is equal to 0. So this equation over here can be written like this. All right. So moving ahead, we can write. So we get the first root, which we already had, y is equal to 1, and then we get y squared is equal to 4, which means y is equal to plus minus 2. Now we have three cases. Y is equal to 1, y is equal to positive 2, and y is equal to negative 2. Now we assumed earlier that y is equal to 2 power x. This is what we assumed. So we can say 2 power x is equal to 1, which means x is equal to 0. So this is the first root of the equation. Then we get 2 power x is equal to 2, which means x is equal to 1. So these are the two real roots of the equation. Finally, we have 2 raised to the power x is equal to minus 2. Now this is interesting. How do we solve this? So let us begin by rewriting the right hand side as minus 2 can be written as 2 multiplied by negative 1. Now let us take the logarithm, the natural log of both sides, which is log to the base e. But we'll just write it as log. So we get x log of 2 is equal to log of 2 plus log of negative 1. Now x log, so x log 2 is equal to log 2 plus, now log of negative 1 is iota pi 2n plus 1, where n is an integer. Okay, which means x is equal to, we are dividing both sides by log 2, is equal to, sorry, plus iota pi 2n plus 1 divided by log of 2, which means x is equal to 1 plus iota pi 2n plus 1 divided by log of 2. And this, friends, is the imaginary root of the equation. So we have found all the roots of the equation, real and imaginary. So I hope you like this video. I'll see you in the next one.